Abhishek, and today in this video I'm going to demonstrate the uses of classes and object using the Java program. In this following video I'll be demonstrating you to simulate a game of a Hanoi Tower. So basically in the Hanoi in the Hanoi Tower there are there are number of towers are there, and each and one of the source tower will be having number of rings. So basically it is the basic Hanoi Tower program. So in this I'll be dealing with 3 towers and 3 rings. So basically you can see that the A, B, C, these 3 alphabet represent the number of towers: tower A, tower B, and tower C. So you can see the number of rings, and there's a small ring 1, 2, and 3. So the rule of this game is that a smaller tower can only be a smaller ring can only be placed on a bigger ring. Suppose if a ring 1 is in the bottom position, and after that if someone wants to place the ring 2, it won't be placed over ring 1, because the ring 2 is bigger than the ring 1. So in this the 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 game the rule of the game is the particular person have to shift all the rings from A to C using the another tower, which is also auxiliary tower, that is tower B. So so over here in this particular slide you can see that this is the tower A, tower B, and tower C. So this way we'll be running our following program to demonstrate the video. So moving on to the program. So over here you can see that there's I have already typed a program into the Eclipse. So the platform is Eclipse, in which I'll be running the Java program to demonstrate the program. So you can see that import java.utility.scanner. So basically I have used a scanner package has been used because the mode of the user input is taken through the scanner class. So I have created 3 arrays over here: int A, int B, and C. So each array denotes the tower. Previously as I demonstrated on the slide, that tower A, there are 3 towers named as A, B, and C, and the maximum number of disks can be placed in each tower is 3. So while moving further on the program, over here you can see that count A, count B, and count C. Basically these 3 are the pointers. So over here you can see that I've used a setter format. So over here in this, so basically what happens when a particular rings are moved from one tower to another tower, the count of the particular tower increases. So when all the towers, when in a particular tower, when all the rings are empty, the particular count becomes 0. So this count helps to maintain the increment and the decrement of the towers, that how many rings are being incremented into particular tower and how many rings are being removed from one particular tower. So here is the following method to remove and to move. So now moving on to the scanner class. So in this over here you can see that a menu driven program has been created over here. You can see this is the menu over here. As in the previously I showed that this is the menu. So our program the output will be shown in the following format over here. So this is the menu over here, and over here this case 1, case 2, case B, case 2, case 3, case 4, and case 5 and 6. So over here you can see that if a particular user want to move from one tower to another tower, these cases will help them to move the disk from the one particular disk to another disk. So over here now This is the following format in which the output will be displayed on the screen, and this the word display will call the display option of the format in which output will be displayed. So here over here I am creating an object of the class that is Hanoi ob is equal to new Hanoi, and I'm calling that object from the object of the method symboli. So now I'll show you the output of the following program. So over here you can so over here you can see that this is the following format, and all at initially all the rings have been kept in tower A. So first of all we have to move all the rings. So now we'll move the ring 1 to the ring 1 over here. The ring 1 should be placed into the C. So over here it's when A goes to C, that is A goes to C, you can see here that is option 5. Okay, now again we have to, now you can see that this one has been transferred to this row, this tower over here. So again we have to press 1. So again you can see that there's again menu is here. So now we have to move the second ring to the tower B, that is from B to, that is from A to B. So now again what you have to do, we have to again put this one into the tower B, that is C goes to B, that is 4. C goes to B, that is 4. So now you can see this particular row is empty, this tower is empty. So now what we'll do, we'll move the third ring from A to B, A to C, fifth. So now what you have to, now one by one we have to keep all this into the particular tower C. So now you can see that now we can put B to C, and after that A to C, then all the rings will be arranged in order in tower C. Sorry, over here you can see that when if I'll do a particular, when an invalid move will be done, this particular message will be shown into the screen, that is invalid move is there. So now again I'll show you the following program. Again I'll show you the output of the following program. Now you can see that this program is running successfully, and the user has also won this game by moving all the rings from tower A to tower C. So thank you for watching this video.